In the previous video, we looked at the equation to solve for force, pressure, and area. Now let's take a look at a few examples. First, the bottom of an 800 Newton crate measures 1 meter by 1.5 meters. What pressure does the crate exert on the floor? In order to solve this problem, we are finding the pressure. Looking at the equation circle, when we cover up pressure, we see we are left with force divided by area. However, we now have a small problem. We aren't specifically given what the area is, so we need to calculate the area before we can find the pressure. Area of a rectangle is length multiplied by width, so we can take 1 meters multiplied by 1.5 meters, which leaves us with 1.5 square meters as our area. Now we can substitute in the force of 800 newtons and the area of 1.5 square meters to find the pressure exerted by the crate onto the floor to be 533 pascals. In our next example, a tire inflated to 35 psi holds up 1/4 the weight of a 2,000-pound car. What flattened area of the tire is in contact with the pavement? First, let's look at our equation circle. In this problem, we are solving for area, which is equal to the force divided by pressure. The trick with this problem is the force on each tire is not 2,000 pounds. It is only 1/4 of the 2,000-pound weight of the entire vehicle. So to find the total force on each tire, we first need to take 1/4 multiplied by 2,000 pounds to find that only 500 pounds of the car's weight are supported by each tire. Now that we know the force on each tire, we can find the area by taking the 500-pound force and dividing it by the pressure of 35 psi. This gives us a flattened area of 14.3 square inches. In the next video, we will take a closer look at more hydraulic principles.